Welcome to the Point Blank Armor. My name is Dimitri. I'm an armor restoration specialist, and this is T-62 Explained. Till mid-60s, all Soviet tanks were of three types, designated by their weight class: light, medium, and heavy. T-62 is a medium battle tank. In fact, T-62 was the Soviet last medium battle tank. Full combat weight is 37 metric tons. The frontal armor is pretty much identical to the T-55. The thickness of the upper glacis is 200 millimeters. The lower glacis is 175. The sides of the hull are 80 millimeters thick. Most of the similarities with its predecessor are below the turret. Now, let's look at all that is different between the T-62 and the T-55. First and the most noticeable is a much larger turret. With its diameter, it extends almost halfway over the track shelves. A larger turret was necessary to make room for a new, powerful 115mm smooth-bore main gun. Factory designation 2A20. Military code name Molot. Molot in Russian means a large hammer, and it is indeed a hammer. In order to accommodate a larger turret ring, the length of the hull was increased by 386 millimeters. Now you can tell by the different spacing of the track rollers in the rear. The height of the hull was increased too by 27 millimeters. The rear deck plate changed its angle too, from the 17 degrees on the T-55 down to only 2 degrees on the T-62, so it became almost completely vertical. The upper engine deck also changed its angle. From the base of the turret towards the rear, it got itself an angle of about 3 degrees downward. It may not seem like much to you, but it affected the depression of the main gun over an engine deck considerably. The same was done with the frontal upper plate, only with a smaller angle of less than 1 degree, so it's barely noticeable. Now, let's take a look at the suspension. The suspension on the T-62 is a classic torsion bar type, with a front and rear set of track rollers supported by the shock absorbers. These hydraulic-type shock absorbers are necessary to protect your front and rear torsion bars, especially the front one. Since most of the armor weight of the tank is at the front, all of your suspension elements at the front are always under most stress. No upper track support rollers, but what it does have are what's called upper track slap guards. During high-speed movement, tank tracks can sometimes wobble, and that wobble can be so severe that it will damage the upper track shelves. So these track guards were added. The track here is of the early type, also known as OM shot track. The design is very straightforward and robust. This is what you call an open pin design. Now, this is pretty cool. One side of the pin is open, so it always has a natural tendency to work its way out. This raised piece of metal is called a pin hammer. When a misbehaving pin passes it, it gets knocked back in. It is that simple. This upper track roller is also a track tension adjuster. First, you lift this cover like this, and then using a wrench, you turn this nut. And the worm gear at the other end of that nut will adjust the track roller like this. So overall design of this suspension remained nearly identical to the T-54. However, there were some differences. The travel of the track roller arm was increased by about 20 millimeters. That was done in order to make the suspension softer. So the T-62 is actually a smoother ride in comparison to its predecessors. I might disappoint some of you just a bit, but that wasn't done for the crew's comfort. In fact, it had nothing to do with it. Why did the engineers improve the suspension that way? That I will explain to you once we're in the turret. So just bear with me. And now I would like to use this opportunity to thank Battlefield Vegas for allowing this to happen. And if you're planning a trip to Las Vegas, you might want to consider this. You can ride on this tank and yes, you can shoot that gun. This is a live weapon system. You'll be firing a real projectile into a mountain. And I promise you, this is something you will not forget. A heartbreak? You'll get over it. Give it enough time, you'll barely remember her name. But this experience you'll take through the rest of your life. Trust me. Now we're going to look at the heart of this beast. Powered by a 4-stroke liquid-cooled diesel V12 engine. The displacement is about 37.5 liters, V55V. This engine is the further development of the legendary V2. V2 was the engine that saw combat on the streets of Berlin in 1945 in T-34s, IS-2s, and many other tanks. So its heritage runs deep in history of Soviet armor. The transmission is manual mechanical with a multi-plate dry friction clutch. The engine is connected to the gearbox by an intermediate gearbox. So the engine bay component base and overall layout remained pretty much the same as it was on the T-54. But there are a number of things that are different. Most of them were improvements on the original design. Now, the most important one, in my opinion, would be the engine deck cover. Before I explain any further, I would like to make one remark. The early T-62s had an engine deck cover that was very similar to the T-54. What you're looking at here is the late type engine deck, or others call it a second generation T-62 deck. Now, what's so special about it? Well, on the T-54, right here in the upper section of the cover, there are two access panels. One would be for the engine, the other one for the airbox. The reason for those access panels is actually kind of a shitty one. Let me explain. Anytime you need to do any kind of a major service on the T-54, you will need an entire engine compartment open. And to do that, you need to first drain the coolant out of the coolant system, disconnect all the tubes that are going to the radiator, and only then you can completely unbolt the engine deck cover and lift it off. The reason for that is on the T-54 and T-55 tanks, the radiator is actually attached to the engine deck cover. On the T-62, they fixed that. On this tank, the radiator is now actually attached to a beam that runs across the engine bay. So you can lift the engine cover off, and if need be, you can remove the radiator too. Here at Battlefield, we love this setup. It makes our lives a lot easier. Another important improvement of the T-62's engine is its power output. It went from 520 horsepower on the T-54 up to 580 horsepower on the T-62. How this was achieved, I'll show you in this next clip I filmed when we were servicing our T-54. Right here I'm standing over a T-54M engine bay. T-54, T-55 is pretty much the same. Here's the T-54 airbox. Now if you look at it, it looks pretty much identical to the T-62, except for there is one tiny little difference. Each one of these tubes, that's where the air gets sucked in, they have this opening on the side. The air gets sucked in, it creates the centrifugal motion, and that's how it gets rid of the heavy elements. Basically the dust, dirt settles down in the tray in the bottom. Now, what is different on the 62 airbox is that each individual windows on each one of these tubes are considerably larger. They're almost double of the size. So we are pretty sure that's how they did it. Another possible difference is in the fuel system. For example, this is your mechanical injection pump, your fuel injection pump. Everything is mechanical here, no electronics. There are different ways to set this, like for example, there are winter settings, summer settings, and so on, so the injection pump could be set differently. So, if you like what you see so far, I would like to recommend another YouTube channel for you. They are our partners. If you want to see more about incredible engines, rare weapon systems, and legendary aircraft, MAC, Military Armaments Company, definitely check it out and subscribe. You're going to see it in the link below. This is where T-62 is most different. The origins of this design go back to the experimental Object 140. Object 140 was a concept in development that never made it into production. Despite its overall failure to succeed in a competition against a future T-64, many of its components ended up being implemented in the development of the T-62. Looking at it, we can see that this is a single-piece cast turret. On a T-54, the turret was cast, part welded on and part bolt-on sections. Ballistically, all of those weld and bolt-on sections were considered weak points. So it was decided to go with a full cast design. T-62's turret is almost a perfect sphere. Mathematically, a sphere has the highest ratio of volume to surface area of any three-dimensional shape. So, hemispherical shaped turret requires less armor to cover a given internal volume. As a result, T-62 has a larger internal volume than the T-54 turret, but weighed almost the same, and at the same time provided better protection. The most well-armored part on this tank is at the front of the turret. Maximum thickness is at 258 millimeters. On a loader's side, we can see a revolving hatch with a mount for a 12.7 millimeter Deshika heavy machine gun. Another remark, on the early T-62, a loader's hatch was of a different design. The machine gun mount was absent, and because of that, the shape of the turret was different too. In late 40s and 50s, a heavy machine gun on top of the tank mainly served as a form of air defense, even though limited. But by late 50s and early 60s, planes began to fly so fast that this type of air defense became useless. That is until ground helicopters came onto the scene and machine guns were returned back onto the tanks. Here at the front, you're looking at a large IR light. This is part of the early type active night vision system. Although effective, if your adversaries are equipped with ability to see it, instead of a solution, it can become a problem. Here at the rear, you're looking at a famous spent shell ejector hatch. This is another unique feature of the T-62. We will go over that one once we're inside. This armored cap is part of your air filtration system. This is part of a snorkel equipment. Most Soviet tanks are equipped to cross rivers up to 5 meters deep. Your turret lifting hooks, 2 in the front, 1 in the rear. Number of optics. This is your commander's periscope. Gunner's telescopic sight. Now let's get inside and see how it works. Here I present to you the world's first smooth-bore main tank gun, U-5TS, also known as 2A20, 115 millimeter, equipped with a 2-plane stabilizer and an automatic shell ejector. The gun breech is just massive. The internal volume of space in 62 is greater than the T-55's by about 1.1 cubic meters. It doesn't feel that much more spacious because of the size of the gun. Let's now look at the component base and see what makes it work. So the largest element of this weapon, other than the gun barrel, is the breech. The breech block slides sideways as it does on most Soviet tanks. Horizontal type breech blocks are usually preferred by the Soviet engineers over the vertical kind because of the compact nature of most Soviet tanks. And it allows for a better depression of the gun. During live fire, breech block closes and opens automatically. But if there is a problem, this large handle allows you to manually open and close it. Right down here, you're looking at a recoil and replenisher cylinders. When the gun fires, it compresses the hydraulic fluid inside of a recoil cylinder, therefore softens the impact of the recoil. The replenisher cylinder's job is to push the gun back into battery. On the loader's side of the gun, you can see a measurement scale. This scale allows the loader to check the health of the recoil system. You reset it back to 0 like this, and next time this gun goes off, the position of that arrow will show you if you need to add fluid to your recoil system, or maybe if you have a leak and you're in need of repairs. On top here you have a manual trigger reset. You're going to hear me say word manual a lot, because in Soviet tanks almost everything has a manual override. Normally this gun is engaged by the electric trigger. But in case anything goes wrong, right here on the left, you have a manual trigger. Now back to the right side. This is the loader's safety switch. When the gun is loaded, the loader will let the gunner know that it is safe to fire by hitting this switch. The gun is on safety until the loader engages the switch. And the switch also has a manual override. Now, to further reveal the secret of this gun's success, I would like to mention such quality as balance. In fact, 2A20 was one of the most well-balanced weapon systems of its time. Throughout World War II, all tank builders of the world had struggled to overcome one fault that all tanks of that time shared. That was their inability to engage targets accurately on the move. All of that began to change in the 50s. Tank guns were becoming stabilized. Single plane stabilizers at first, and soon after, two plane stabilizers became reality. Now, tanks could engage targets effectively not only on the move, but while turning at the same time. As a result of progress in gyroscope and electronic technology, one particular quality became very important for the tank gun designers, and that is a balance of mass between the breech block and the gun barrel. This is important because on a well-balanced gun, gun stabilizing equipment becomes more effective. It simply doesn't have to struggle with the weight of the gun in order to correct its position. Now, how this was achieved here, it's genius in its simplicity. Tank builders around the world found different ways to solve this problem. Some simply added artificial weights onto the breech block. Others shifted the gun deeper inside the tank by moving the position of trunnions forward. But none of those solutions were ideal for the Soviets because of the constraints in size and weight of their tanks. If you shift the tank gun inward, you will lose interior space and will probably have to redesign a larger turret. The outcome is obvious: a runaway effect in size and weight of your tank. So the engineers of UVZ chose a different path. They took part of the gun stabilizing equipment, some of its heaviest elements, and attached it to the bottom of the gun. Right over here you can still see some artificial weights, but it is clear that this is just a minor adjustment. And now I would like to touch back on what I said earlier about the T-62's softer suspension. Smoother suspension simply compensated for some of the need to overcorrect, therefore making the gun stabilizing equipment's job easier and as a result more accurate. It's time to look at that most distinctive feature of the T-62, the famous span casing ejector. So the ejector works in one continuous sequence. After the gun is fired, the breech block opens automatically and a spent shell is ejected onto a tray. The tray then is lifted to align with the ejector door. This mechanism, powered by an electric motor, opens the armored door, and the spring-loaded mechanism ejects the shell casing. This ejector is vital to the operation of this tank, and I'll show you why. As you can see, this is a big shell for a relatively compact tank. And having 10 or 20 such shells rolling around on the floor can easily become hazardous to the crew. The ideal, of course, is to place the shells back into the ammo storage bins. But again, this is a compact tank. In combat conditions, this may not always be an option. T-62's ammunition storage consists of 3 general areas. Right down here by the engine firewall, up to 20 rounds can be stored. By the loader's right shoulder, we have the additional space for 2 more rounds. These are so-called ready rack rounds. This ammunition is usually used first due to its vulnerability of being under the thin part of side armor. And we have the two forward-facing stowage bins to the right of the driver. They hold 8 rounds each. As it sits under the main armor plate, this part of the ammo load is the most well protected. Another interesting feature about these stowage bins is that they are fuel tanks as well. Now, before you think to yourself that these Soviet engineers have lost their mind by placing ammunition inside their fuel, you should know that the diesel fuel does not ignite well on an impact. And these stowage bins, being fuel tanks, actually serve as a form of protection to the ammunition. Not against direct impact, of course, but in case of armor penetration elsewhere, it adds some degree of protection against possible shrapnel damage and keeps the ammunition cooler too. On the right of the main gun, we have a mount for 7.62mm coaxial machine gun, PKT. We do have the gun for it, but for safety reasons, it's removed at the moment. A couple of interesting features. The gun itself is modified for a remote trigger, so it can be operated from the gunner's position on the opposite side of the main gun. Standard, you will have 2,500 rounds of ammunition available to you for this weapon. The canvas bag here will catch your spent casings. Now, over at the gunner's position, this is your turret traverse mechanism. It can be operated in two ways. Electrically, by the main gun control unit, or by changing this tab's position, you can declutch the electric motor and you can turn this turret by hand using this handle. This large indicator here shows you the position of your main gun in relation to the hull of your tank. You need that in communication with your driver in order not to damage the main gun by running into a wall, a tree, or any other obstacle. The gun control unit allows you full control over all weapon systems on this tank, except for the DSHK on the top of the turret. That one can only be operated by hand. Turning this entire unit left or right will turn your turret, and by moving these handles, you will elevate or depress the main gun. The left button is the trigger for your coax gun. The one on the right is your cannon. The gunner's telescopic sight we do not have, unfortunately, but we are searching for one. The missing sight is supposed to be a Tesha S41U. In parity with the main gun, it's ranged for direct line of sight targets up to 1,600 meters. With coax machine gun, it's ranged up to 400 meters. Over to the left, we're supposed to have our night sight, TPN 141. Its maximum range for tank type targets is up to 800 meters. Now let's look at the commander's periscope, my personal favorite, and I'll show you why. It's also equipped with a night vision capability, but the really cool part, it has the feature called Commander's Override. With this revolving cupola, the commander has the ability to search for targets independently of the position of the turret. Once he designates the first priority target, he has the ability to override gunner's controls by flipping this switch. So the turret will automatically swing around to line up with the commander's sight. This is like an early form of hunter-killer system. In my opinion, pretty advanced for 60s technology. This is where T-54's heritage is most evident. No major changes were implemented here, other than the driver's seat that got redesigned elevation mechanism. Next, let's take a look at a starting sequence of this tank. Step 1, you set your idle. Step 2, you need to prime your engine. Priming your engine means bringing your oil pressure inside of your engine block up before you start the engine. You do that by turning this tab and holding it for a few seconds while the electric pump is pumping the oil. When the oil pressure is right, you turn this same tab the rest of the way into engine start position. By doing that, you will engage the air start. On most Soviet tanks, there are two ways of starting an engine. With the electric starter, or with compressed air. The air tanks are behind the driver. The air star on Soviet tanks is actually quite sophisticated. To turn the engine, the compressed air is being shot into each cylinder in proper sequence. Once the engine turns, you press the clutch, press the brake, select your gear, let go of your brake, let go of the clutch. However, there is one more step to starting this tank, and I'm not going to share that one with you for safety reasons. This next part is pretty important. You do not ride the clutch on these tanks. This isn't your car. The clutch plates here are metal, and if you overheat them, you can literally melt them together. These large handles is what you use to turn the tank. By pulling it towards you, first you're going through the gear reduction in your planetary gearboxes. But then if you continue to pull it the rest of the way, it becomes a brake. When you pull it the rest of the way, you're tightening the brake bands around the planetary gearbox drum. And by doing so, you're slowing down the speed of that track. This is your speedometer. With this handle here, you control the flow of air to your engine. The instrument panel stayed pretty much the same from the T-55. This is your tachometer, oil pressure, oil temperature, water temperature, and your voltmeter. And the missing gauge here would be your engine hours. Most of the Soviet military vehicles we get, the engine hour gauge is usually missing. And right up here, your fuse box panel. Everything you see in red is part of the fire suppression system. This here will allow you to control the flow of your fuel. Right up here, there are directions. Depending on how you set this handle, it'll mean which fuel tanks you'll be drawing fuel from. The exterior fuel tanks usually are the ones you would want to draw your fuel from first, because these fuel tanks are unprotected. And then you switch to your internal fuel tanks. Right up front here, you have your driver's periscopes. Tankers train extensively to learn to drive a tank by only using periscopes. So, now you can see that seemingly a simple feat of placing a bigger gun onto an existing platform, in reality it was a very carefully calculated approach, with which engineers were able to answer to the military demands with their strategic requirements, and at the same time designed a tank that fitted well into doctrinal and economical reality. With a firm increase in firepower and accuracy, most of the component base below the turret was interchangeable with its predecessors. That meant that a large portion of logistical infrastructure was already in place for a new tank. And the training for tank crews remained similar. I wish that we no longer had need for such machines. But I find it fascinating that more than half of a century later, this tank continues to prove its worth on the battlegrounds of the world. Thank you for watching. And if you liked what you saw, like and subscribe. That will help me create more quality content for you.